have we discussed so far? Okay, so far we have discussed some different types of ordinary differential equations. Okay, first of that is, so we have discussed separable differential equations, and then what is our goal? Our goal is to get the general solution. Okay, this is our objective. Okay. Next type of ordinary differential equation that we have discussed is we have exact ordinary differential equation. Okay, so we have discussed some methods in how to get the general solution of these types of ordinary differential equations. Okay, the third one that we will discuss this afternoon is about homogeneous linear ordinary differential equation with constant coefficients. Okay? So medyo mahaba yung kanyang pangalan. So we will discuss one by one what is homogeneous, what is linear, and what is having a constant coefficient. Okay, so if I will erase this one. Okay, and we'll concentrate about homogeneous linear ordinary differential equation. Okay, so first, when can we say that it is linear? Okay, the general form is this one. You have y to the n plus y prime okay. We can say that it is a linear ordinary differential equation if it obeys this format. So what have you noticed in this form is that this one is your coefficients, okay, or functions, and then ito yung titingnan mo, ito na part dito. So dapat ang kasama niya is only a function of x. So hindi pwede na may y na variable dito, hindi pwede. Okay, and then this one is your right hand side of the equation is a function of x or 0. Okay, now in the event that this term r of x, when r of x is equal to 0, that's when you say that the equation is homogeneous. Otherwise, if r of x is not 0, then it is a non-homogeneous ordinary differential equation. Okay, let's take some example. You have y double prime plus 4xy prime plus 2y is equal to cosine x. Is it linear? Is it non-linear? Okay? So this one is an example of a linear ordinary differential equation. And then since you have this one, so this is non-homogeneous ordinary differential equation. Okay, another example. You have y double prime okay, is it a linear or non-linear? As you have observed, medyo similar sila nitong number 1 example. But, ang naiba lang is ito na part. Okay? Since meron siyang y na variable dito, this makes it a non-linear. Okay? As long as function of x dapat yung nandito. Any function of x, kahit may sine or cosine, as long as there's no y. Okay? This one. Y double prime is this linear or non-linear? Okay? This is non-linear. Why? Because of this sign. Trigonometric man ito, hindi man ito linear. Okay, so based on the format, dapat y lang. Y. Okay? So hindi pwedeng may anything sign. Okay? So I hope you have a malinaw sa inyo yung linear or non-linear. Okay? Okay. Last. This one. Y double prime plus is this linear or non-linear? Okay? This is again, since hindi ito equal to 0, this is non-homogeneous linear. Non-homogeneous linear. Why? Because ito based the format, okay? This term, kahit cosine to or e to the negative x, as long as function of x only, linear pa rin. Okay? Okay, so just like the separable and exact ordinary differential equation, our main objective is to get the general solution. So how do we get the general solution of a, let's start first with homogeneous when this one is equal to 0, because it is much easier than compared to non-homogeneous. Okay? So let's start first with homogeneous linear ordinary differential equation with constant coefficients. Okay, constant coefficients. Meaning, anong general form niya? General format. Okay, ang general format niya is this one. Let us start first with second order. Okay, second order meaning y double prime. Okay, so ito yung general format niya. Okay, this is linear equal to 0, homogeneous, and then yung coefficients niya or dito yung p of x is a constant, a and b. Okay, before we proceed with the general solution of this homogeneous linear ordinary differential equation, let's discuss first these theorems. Okay, theorem number 1 is states that, I will read, let AB be an interval in which P of x, Q of x, and R of x are continuous. Okay, so sabi dito, if we have an arbitrary point x sub o within the interval AB. So ano tong AB? Ito yung range of values na merong that are solutions to this differential equation. Okay, so then if we have XO, ang corresponding value, y value niya is y sub o, and if we get the first derivative, we will get y prime of 0. Okay, so if i-substitute natin yung mga values na yun dito sa differential equation na ito, we will get a solution. Okay, in terms of this, only one solution. Okay, so saan ba natin ito magamit to na theorem? We will use this later on in our solutions for homogeneous linear ODE. Okay, theorem number 2 states that if y1 and y2 are any solutions of the homogeneous equation y double prime plus p of x y prime plus q of x y is equal to 0, then we can combine those solutions into this one, general form of y3 is equal to c1 constant times the y1 plus constant times y2. Meaning, if you have two solutions from this equation, pwede mo yun i-combine into a general solution. Okay, which looks like this. Again, we will use this one later on. Okay, so there is also some theorems in the book which we will not discuss, but we will proceed with on how to find the general solution of this second order homogeneous differential equation. Okay? Okay, so this is the general form for a second order linear ordinary differential equation. Okay, so according to the book, ang solution daw nitong differential equation na ito is this one, y e to the mx. This function now is a solution to this. How did he get this one? Okay, so if we start with a first order linear differential equation, Okay, so ito yung first order. Okay, how do you get the general solution of this one? Okay. You get by separating the variables. Okay, so you have ln of y negative kx plus c. Okay, you raise this one to e, you will get y is equal to c e negative kx. Okay, so this is the general solution of the first order linear differential equation. Now looking at this one, so the mathematicians propose that this form is also, basing from this one, they postulate that this function is also a solution to this general second order differential equation. Okay, how do we check na solution talaga ito? Okay, we can check by using theorem number 1. Okay, if we substitute this function into this one, okay, so first we get the first derivative, which is m, second derivative m squared. Okay, we will now substitute this here. We will get m squared plus plus am e to the mx plus b. Okay, let's plus, okay, so we come up with this equation. Now in order to satisfy this, that ito magiging 0, so e to the mx, kung hindi ito 0, so dapat ito maging 0. Okay, therefore you have m squared plus am plus b must be equal to 0. Okay, so, and then how do you get the value of m? You can get by applying quadratic formula. Okay, now kung makuha mo ang m and then i-substitute mo dito, you can now get the solution of this differential equation. Okay, so let's find, I will now erase this one. Okay, using quadratic formula, m is just negative a plus minus square root of a squared minus 4b over 2. Okay, now there are 3 cases for this one. No? Case 1, if this term a squared minus 4b is greater than 0, you will get 2 real roots. Okay, 2 real roots. If positive daw ito, you can get an m value that is real numbers. Okay, now for case 2, if a squared minus 4b is equal to 0, ang makukuha mo na m real double root. So, sa anong ibig sabihin? You'll get a real number and then it is repeated. Meaning, the same number yung makukuha mo. Repeated siya. And then for case 3, when a squared minus 4b is less than 0, you will get complex conjugate roots. Okay, why is it necessary to identify whether case 1, case 2, case 3? Because depende sa case, mag-iba yung general solution mo. Okay? By the way, this one is what we call the characteristic equation. Okay, characteristic equation because it will determine kung saan siya na-belong, no? Kung ano yung roots na makukuha mo, whether real or complex or repeated roots. Okay? Now, medyo madali lang naman ito, case 1 and case 2. So, let's have an example for case 1 and case 2. Okay? Now, I will now erase this one. Okay. For case 1, case 1 and case 2. Okay. You have y double prime plus okay. So again, this is linear homogeneous ordinary differential equation. Okay? So, importante na determine mo yung format, no? 12y. Now, in the event na 12 lang ito, walang y, so i-transpose mo ito sa kabila. And then, hindi na yan homogeneous, nagiging non-homogeneous na yan. So, dapat mayroong y. Because based on the format. So, tingnan nyo mabuti yung format. So, ano ang first step? First step is we change this one into a operator notation. So, ang y double prime is equal to d squared y over dx squared. Okay? But d over dx is equal to capital D. So, magiging ano ito? D of dy dx. Right? And then, simplify natin further. Magiging d of dy, or this is the d squared y. Okay? D squared y ang y double prime. Okay? So, based on that one, this becomes d squared y plus 7 dy plus 12y is equal to 0. Okay? So, ano ang gagawin natin dito? select the y. Okay, b squared plus 70 plus 12 is equal to 0. And then this is now will be your characteristic equation. No, so this term must be equal to 0. So your characteristic equation i-change natin yung variable d to m. Why? Because m yung ginamit natin dito, no? M yung ginamit natin dyan. So okay, this becomes m squared plus 7m okay. Now you can apply quadratic formula or just factor this out. You will get m1 is equal to negative 3, m2 is equal to negative 4. You will get ano ito, case 1 dahil you get two real numbers. Okay, so second order you will get 2 roots, third order you will get 3, and so on. Okay, so based on this one, we will now apply theorem number 2. Okay, so there is this one. Based on theorem number 2, your general solution will be y is equal to constant c1 e to the m negative 3x plus c2 e to the negative 4x. Okay, this is now your general solution. Okay, so medyo easy lang nito. So pwede natin itong apply to higher order linear ordinary differential equation. Okay, example, third order, y triple prime minus 2 minus 4y prime plus 8y is equal to 0. Again, change this to operator notation. Okay, now your characteristic equation would be m cubed minus okay, how do you factor this out? How do you get the roots of a cubic function? You can apply synthetic division. Okay, 1, negative 2, negative 4, and 8. Okay, let's start with 2. So, kung nalimutan nyo yung paano gawin yung synthetic division, just review. Okay? Okay, since naging 0, 2 is a root of this equation. Okay. So, anong ibig sabihin nito? Ibig sabihin nito, since m cube, so, change mo lower down yung exponent nito, magiging m squared 0 minus 4 is equal to 0. Okay? So, ang factor nito is m squared minus 4, and then ito m minus 2. Right? M minus 2. M minus 2. And then you can factor this out. This becomes m plus 2, m minus 2, m minus 2 equals 0. So you have 3 roots. M1 is 2. M2 is M1 is negative 2, M2 is 2, M3 is 2. Okay, so you have repeated roots sa case 2. So, anong gagawin mo kung mayroong repeated roots? Yung general solution mo would look like this. Okay, kung mag-start tayo dito sa 2, you have C1 e to the 2x, e to the mx, plus C2, since repeated, maglagay ka ng isang x, x e to the 2x, and then ito C3 e to the negative 2x. So this is now your general solution. Okay? What about if meron kang roots na what if ang roots mo is ito 2, 2, 2, so repeated for 2. Okay, so general solution mo niyan is y is C1 e to the 2x plus C2x, maglagay ka ng isang x, e to the 2x plus C2x squared e to the 2x. Okay? So, kung kailan i-repeat, dagdag ka ng isang x. Kung 4 na beses nag-repeat yung roots, so magiging C3x cube. Okay? So, ganyan lang yung isa. And then, let's have an example for case number 3. So, kung for case number 3 naman, y double prime plus okay. So, anong nangyari dito? Change this one. Okay, your characteristic equation will be m squared. Yan. Huh? And then, how do you get the root of this one? Di mo man ito ma-factor, so you will apply quadratic equation. So you have negative 2 plus minus square root of 4 minus 4 times 5 over 2. Okay, so ang root mo ngayon is negative 2 divided 2 is negative 1 plus minus 4 minus 20 is 16. Square root of 16 is 4 divided 2 is 2. 2i. Okay? Yung negative man yan. Okay? So, you have a complex number. Now, case 3. This is case 3. Okay, for case 3, how do you get the general solution? You will use this format. Y is equal to E to the px E cosine qx plus B sine qx. Yan. So, ano yung what is P and Q? What is P and Q? So, P and Q is just this one, P plus minus QI. So, looking at this one, in this format, M is negative 1 plus minus 2I. So, ang P mo ngayon is negative 1, your Q is 2. Okay, therefore, your general solution is y is equal to e to the negative x. A, ano yung A? Yan yung constant. A cosine 2x plus b sine 2x. This is now your general solution. Okay? So another example. Let's have an example higher order. Okay? Y to the fourth y to the fourth plus y triple prime 8 y double prime okay. Again, change this one to operator notation. Your characteristic equation would be m to the fourth plus okay. So this is your problem now is how do you get the root of this one. You can apply again synthetic division, pero kung in the event na hindi mag zero yung last term, so hindi yun root. So sa algebra na ito, no, algebra which is inuro dito sa high school niyo or college, okay, by trial and error you will get this one, m squared that one repeated. Okay, kung i-multiply mo ito, you will get this one. Okay, so review your factoring. Okay, how do you get the root of this one? Again, the root of this one is makuha mo by quadratic formula, which is m is equal to negative 2 plus minus square root of 4 minus 4 times 2 is 8. Therefore, ang root mo ngayon is, since raised to 4 mo ito, so you have 4 roots. Negative 1 plus minus 4 minus 8 is negative 4. So, negative 2i divided 2, you have I. Okay? And the same on this one. Negative 1 plus 1 minus I. Okay? So, repeated roots. So you have case 3 and case 2, repeated roots. So ano ang magiging general solution mo ngayon? I will erase this one. Your general solution would be y is equal to, again, using this format, e to the px a what is your p? Your p is -1, your q is 1. Okay, so you have e to the -x a cosine x plus b sin x. And since repeated siya, nag-repeat yung root, so you have plus x e to the -x c cosine x plus d sin x. So that is now your general solution. I hope you understand how to determine whether linear, homogeneous ang isang equation, isang ordinary differential equation. And then, after identifying that one, you can now get the general solution using this method. Thank you.